Good afternoon. It is 1 in the afternoon. And I'm going to be doing something else today. I am pretty much burned out on working on water stuff for Dashkin. So today I'm going to design a backend server that we might use. So kind of the idea is we may want some sort of backend services for this game. And we are going to want to be able to do stuff with that. So maybe not like real-time multiplayer instance servers or anything like that, but we're going to need a few things set up if we need to do some basic actions. Like we need, let's say we need to collect telemetry on how our game is doing. Let's say we want, crash reports to get submitted. We want just anything, like if we ever had any multiplayer elements, we're going to need a whole bunch of different stuff. So what are some things that we need for our backend service? So it's not like a multiplayer game server. I mean, let's see. Game backend. So what are we going to need? We're going to need some sort of authentication / login. We're going to need some cache persistence layer. We're going to need a persistence layer, so a database. We're going to need a push notification system. Need all sorts of stuff. So let me find what I was looking for. So what are some other things we're going to need? We're going to need our actual logic system. It's going to have like an RPC based RPC place. We're going to need a way to configure all that stuff. We're going to need a way to deploy it and manage it. And we'll need health and monitoring of that thing. Alright, so let's see. We're going to need... Let's just start writing stuff down. So we're going to have our client, which is going to be whatever. We're going to have two ways of communication. We're going to have our HTTP stuff. We're going to need like a TCP connection as well. So what are we going to do? We're probably going to have some sort of load balancer with a SSL termination. And we will also need all sorts of stuff. Alright, so we're going to need some sort of auth service. So we're going to need... So we'll have like HTTP only, some sort of auth thing over here that we have to log into. We're going to need that to go to auth cache. We're going to need our app server. We're going to need some sort of relay, which is actually going to tie back into the app server. And each one of these is going to need its own sort of system going on. So let's think. Alright, so that's probably our basic architecture for everything. Let's see, how does everything work? So we need to know how login works. Alright, so we'll do a HTTP call to auth service. We're probably going to have some sort of OpenID compatible thing, like login with Facebook, login with Twitch, something along those lines. Actually, we'll probably log in with Twitch. That would not be a bad idea. Should we use Twitch to log in to start with? Or should we just... that would be a decent one. So we can basically support any OpenID thing probably pretty easily. Alright, that auth service will create a secure token. Slash create account for user. Let's see, we'll then connect over HTTP to app server and create secure TCP tokens. And then we're going to connect over TCP ident with secure token, and then we're done. We're logged in. So that should be our basic server architecture, I believe. Let's go ahead and color this because I feel like it. Hooray, pastel colors. And databases always get a brown color, if I can get one. Because they're always the shit. So how are we going to set all this crap up then? Let's see how we're going to do configuration, how we're going to do deployment, how we're going to do all these things. So the relay server is going to do our push notifications over TCP, cache persistence, authentication and login, push notification logic. Logic will exist inside of the app server. So all the things that we're going to need to write for all this stuff. Hello, Chris Goku 2. I am not actually doing a whole bunch of graphics crap today. I am working on designing a backend service for this game, which will do things. So we'll need all the things for a game. So I need to come up with kind of what pieces and parts I'm going to use, and then I need to figure out how much all that crap is going to cost. And I'm going to figure out which technologies I'm going to use in the whole thing, and we'll see. If I can get through planning of it, I can then actually get started working on some of it. So I think the idea is that we'll have all these servers. Our servers, I believe, will just be I think we'll have Java servers because it's easy for me to write. I've already got a lot of code for Java. I think our game database is just going to be simple. Just use MySQL or authcache. Of course, we're just going to do memcache. So that'll be simple. Let me see. I mean, of course, we're going to be running this stuff on like AWS. So I need to go take a look at how much all this is going to cost. You haven't studied databases, couldn't find a college course on it. Yeah, when I was in college, like, we didn't even have a database class, right? So like, that was when I didn't know anything about databases. It was nuts when I went in. Alright, so I need to look at my total costs. Right now, my account is using, it's costing us like $9 a month on AWS. And what is my setup at the moment? My setup at the moment has got our website, which has, I think, a load balancer in the front. Man, AWS is all sorts of screwed up with their website. Wait, so I have 4 load balancers? Alright, so load balancers are pretty cheap. You'll have someone teach you when you finish your game. I don't know, databases are... Alright, let's see. It's 2 cents, 2.5 cents per hour. Alright, so if we have 0.025 times 24 times 31, we're looking at like 20 bucks a month supposedly for an ELB. Alright, so let's assign some price tags to some things here. And let's see what's an RDS instance, if I should actually go to RDS for stuff. Yeah, databases basically, I've worked with NoSQL databases like Mongo, Cassandra, things like that, some Redis. I've worked with like Microsoft SQL, MySQL. I've worked with DynamoDB and all those sorts of things. I've worked with SimpleDB. I've worked with lots of different databases, and at the end of the day, I just recommend use MySQL. It just fucking works. Alright, so a database, we could get a T2 micro. Oh, come on, Chrome, don't be locking up on me now. I'm just trying to read some goddamn prices in a spreadsheet. Alright, so it's like 0.017. So it's like 13 bucks an hour. And this is one part of server development that you need to cost in. Is with your server architecture, you want to know how much it's going to cost. Alright. And then you'll find Windows 7 and do that old head first book or something. Well, it's really easy for MySQL and stuff like that. Just get the MySQL workbench online, and it'll install a local MySQL database for you if you follow like all the basic instructions, and then you'll have a database ready to go. The tools are great and just work, and you can use any language that you'd like to interact with that and just play around with it. Stuff like that. It's I don't know, a lot of like the academic courses on databases and stuff like that I find incredibly boring. You know, they're like, oh, you know, let's make a table of employees and have employees that have like name and date of birth and salary and whatever the hell. Some of the stuff I'd recommend is try to write some telemetry systems for your game or something like that. So instead of putting in stuff that might be useless, try putting in telemetry. And telemetry events might be like, if you like fired a bullet, if you hit somebody, and how much damage it did, and then where in the map that you hit that person, and like what match you're in, and then you can like pull that data out and then make like a little heat map for your level, and you can see like where everybody dies, and you might do that, for anything. Like you can even manually enter that sort of stuff and like play your own game or pull data from League of Legends or pull data from somewhere, and you can do all that stuff yourself, and it's actually pretty cool. But those kind of academic things I never found useful. It's like just go find a good use that you think is fun. Alright, so let's see. The on-demand pricing for Amazon Linux for like T2 micros is like 12 cents an hour. Alright, so it's gonna be about 12 bucks. 12 bucks a month for a T2 micro, or about 20 for a T2 small. And we can probably get everything onto like a T2 small. So our whole architecture here would probably cost around $50 or $60 a month, plus that. So that's pretty cheap. And then we could always scale it up by moving stuff around. Use Glacier? And Glacier's hilarious because like it's like a service that they wanted to make so it has like, you know, you can't pull your data out very quickly. And so there's all this big deal about, oh, you know, this data will be, you know, somewhere else and made available or something. And I don't, like last I knew, they didn't actually implement anything differently. Like they're just using S3. They're just charging you a different price while they try to figure out how the hell to make it less expensive. So I always thought that was really funny. Oh god, and I absolutely hate like DynamoDB and a lot of the NoSQL stuff. I would recommend never touching any of that crap. So many games I have seen die on that mountain. And it's always people who have never actually used like a relational database or know anything about database administration will like go be like, oh, you know, I can just Cassandra Mongo my way into like a web scale architecture, and be like, just knuckle down and do the damn work. Like there's a reason everybody uses, you know, Oracle and MySQL and Microsoft SQL and pays out the ass for it. It's because it works. And they kind of solved the database problem in the 80s. You just gotta make a real system. And the only other innovations are like big data sorts of things, and that's just a completely separate concept of like solving MapReduce problems and making stuff so that you can actually pull data out without killing yourself. Alright, so I think this is our basic architecture. So where are we going to have our configs? So why don't we just write down our basic stuff? So push notifications. So that's when we need to be able to send a message to a specific user that's logged in, or a specific service, though I don't think we have any specific services because we don't have like actual specific game instances. Alright, so app server calls the relay. The relay is going to need to look at the cache to find the app server, which has a user. Relay sends message to app server. App server sends message to user. User sends response. So that's how that push messaging system will work. And we can shortcut it if you're logged into the current app server, it'll work, otherwise we'll go over these. I don't know. The fastest way to learn is to make huge mistakes. I would know that. Alright, so if we got push notifications for our persistence layer, we're just going to use the database. I'm not going to worry about a bunch of caching bullshit for the database. I don't think we're going to have much scale to worry about. Alright, so for our logic system, let's see, RPC into thread pool, one thread per request, limit of And since we're using Java there, I don't think there's any like fibers in. There's no way to do fibers in Java, as far as I understand, without using like a bunch of experimental bullshit, which I don't want to do. Well, one of the things here, just C++ then? Well, yeah, that's kind of like when I was working at EA, their backend, like Plasma and Blaze servers, which would be stuff that's running like Mass Effect 3 and a lot of those big name things. They're C++ backend servers. They use fibers for everything. It's a really cool system. Basically, a fiber is a thread, but it's lighter weight. And the idea with a fiber is that you can resume its execution. So it's kind of an issue with server design is that you have a whole bunch of requests that come in, and if you have like one thread per request that's currently being active, what's going to happen is you can only have a certain number of threads because you only have a certain number of memory, and it's not a problem if your requests take no time to execute, right? Because then you just like chew through all your messages, no problem. What becomes a problem is if you're calling an external service, like if you have to call the database or you have to call an external e-commerce thing, and the speed of light to that other service is like 100 milliseconds, then you could only have like... Yeah, the idea is it's not actually like a hardware thread, it's the ability to kind of jump back into a context. So if you only have like, if you have 200 real threads, that means you can only have like 200 outstanding calls to an external service. So if the external service took 100 milliseconds to respond, you can only have a certain number of you can only have a certain throughput based on your thread number. And what a fiber would allow you to do is, instead of having only like 200 outstanding calls, it allow you to have like 10,000 outstanding calls, so that like 100 milliseconds starts to not matter at all. Yeah, forking a thread takes time. You'd already have the threads already allocated, so it has nothing to do with actually forking the thread, and the thread locking stuff is never really a problem either. It's always external service I/O. It's always going to be a database that is slow to respond, or an external service that's taking like X number of milliseconds to do something. So like if your call is taking 100 milliseconds and you have 200 threads, you can only have 200 things outstanding. So basically, it's going to be 200 multiplied by 0.1, which would be 1,000 milliseconds divided by 100 milliseconds. So your theoretical throughput rate is just going to be like 2,000 requests per second if you had 200 threads, which is pretty good. 2,000 TPS is pretty awesome. So that's close, but we could probably have a higher theoretical TPS. Like if I'm writing a server, I usually want around 5,000. So yeah, a fiber is a little bit different, because how a fiber works is you have a context and you have an execution point. So basically, like your context would have like your request, the thing that you're actually trying to do, and your execution point is like where in your service call you actually are. So with a fiber, what you could do is like you would have it stop. Like you'd be like, okay, I need to go call the database. So what it would do is it would just like, okay, it would start the database call and then suspend itself, and it would stop doing something, and that thread that suspended this task can go grab another task, and start executing it while this thing is suspended. And when that database call comes in with the information that you fetched, you can resume that that fiber at exactly that point. So this thread would, yeah, it's like you'd basically go to that execution point and continue executing, and this one thread can just keep executing absolutely everything. So you don't have to worry about like locking stuff in memory. You don't have to do a whole bunch of bullshit with concurrent access. It's not like a regular thread because your pattern is that you only have one actual execution thread, and you have a whole bunch of other threads which are just like fetching the asynchronous data for the thing. So the one thread that's executing absolutely everything basically has all these workers that are just like handing it all these tools as fast as possible. So you can write your code much simpler. You don't have to worry about concurrent access, and you can get, it's much easier to work in. Some hilarious things that happen, of course, are like for loops become incredibly dangerous because the size of an array might change, stuff like that. But everything else is super easy to work with. And it sounds like a regular thread, but it's not a regular thread because it's better. But we're not going to be able to use that because I'm going to run Java on our backend servers, and Java doesn't have GoTo. If Java just had fucking GoTo, I could do it. Like you could hold a context object and just update that. It's basically a program, but it's just a different way of doing stuff. You'd have to. It's difficult to communicate how that actually changes the entire ball game for your server until you've actually like spent some time messing with stuff. But a fiber system is inherently superior for processing your information because of just how much easier it makes your programming and how resilient it is in the face of backlogged crap. Alright, so how are we going to do configuration? I could have configuration exist inside of the database. I could have the configuration exist inside of files. I could have like configuration stuff on files in S3. I like the idea of configuration would be files in S3. So why don't we just do that? So for configuration, we're just going to have files in S3, which point at based on deployment config file. So a deployment config file will tell us where to go for the rest of our configs. And that'll just be JSON files or whatever. I mean, it sounds like a mess, but that's exactly what server engineering is about. It is a mess, and fibers take that, what would be kind of a spaghetti monster of hundreds of threads that are all doing work, and it turns it into basically one thread doing a whole bunch of different work with a bunch of resumes and yields, and a whole bunch of I/O threads that are doing things, and it actually turns it from this giant spaghetti monster into kind of a much more simple system. Also, good afternoon, Lucas. I'm doing server stuff today because I'm tired of screwing around with water. So I'm just kind of designing server stuff. Don't take this as we're going to make like a gigantic multiplayer game for this. Where did you learn all the backend stuff? I'm getting into computer science and I want to learn advanced concurrency networking in Java. I didn't learn any of this stuff in school. I showed up at EA my first day on the job. I got a task that said write a server, and it had the number 30 written on it, which was the number of days I had to learn everything. I didn't know Java. I didn't know how to use a database. I had never used Linux, which we were writing our service for, and I learned it all by making horrible mistakes. So what I would recommend to you is to just get started and make all the mistakes you can. What resources did I use? I used a whole bunch of blood in my body, which I then painted a giant picture with. And that's what I did. So you bought some books and learned it there? No, books are for chumps. Books are for other people. Learning by failing is how I operate. So Lucas, what kind of server stuff? What is it for? So there's a lot of reasons to have some sort of backend service for Dashkin. So like we can record some telemetry and figure out, how people play the game. I mean, you must use a reference at the very least. You can't assimilate that knowledge. You'd be surprised. You'd be surprised what desperate people can do. I literally just sat down and started typing stuff in a horrifying, desperate manner, and after years and years of doing that, you kind of figure out what you need to do. I mean, we had like some tech leads on the team, but they're fucking idiots. So it was a 2-person project. So like we might want to collect telemetry data on the game. We might want to collect crash reports and stuff like that. So if the game breaks, we'll be able to collect stuff. We might have some sort of, systems that we want. So like if we want any data to be stored for an account, all sorts of stuff. So yeah, we're gonna keep track of all those horrible things you do, Lucas. And if we ever want any sort of multiplayer interactions, and we want to do it ourselves with our systems, this would be the sort of server that would allow us to do that. This is not going to be like a multiplayer instance server where like 2 people will be playing in the same simulation, or like Call of Duty or whatever, 64 people playing a deathmatch. No, it's not that. It's kind of the more different thing. So Java is frequently used for lots of online development. There's a lot of reasons for it. It runs real well on pretty much every machine, so you can stick it wherever you want it. There's a lot of tools for it. A lot of Java stuff works together. There's a lot of monitoring stuff that just kind of works. C# would give it a run for its money in just about every field. So Java versus C# is kind of a whatever you want. And it has some advantages over stuff like Python in terms of if you have a larger team, it can be easier to manage something that is a compiled program. And I'd say Java is very frequently used in e-commerce situations, very common in databases, very common in enterprise products. It is less common in games, I would say, mainly because game programmers usually don't use Java. Yeah, Lucas, that's exactly the sort of interaction that this sort of system would allow, but I will not confirm or deny any sort of asynchronous multiplayer. And if you know how to program in Java for servers or anything like that, you will never be unemployed unless you want to be unemployed. There's an incredible number of jobs. I think the biggest online system that I know for games that uses Java is Riot Games uses Java for its backend services. Last I checked. Alright, so I need to figure out how I'm going to do deployment. So I think basically deployment is going to be a single jar file with a single config file. A jar is just an executable Java thing, and we'll use our Jenkins box locally to push it out. So how am I going to deal with credentials? So like, well, I could use KMS. Let me look at KMS real quick, the key management service for Amazon. Let me see how expensive KMS is. Alright, it is 3 cents per 10,000 requests, or... Alright, so 3 cents per 20,000 requests per month. Alright, so KMS is pretty much free. So one of the big issues with server stuff is normally you need credentials stored. Sorry if this posts somewhere, but what are you building? That is a good question. I am building this game. One of the issues with credentials is a lot of people are super lazy, and if you have like a username or password that you use to like log into your database, a lot of people just shove that in a goddamn file on disk next to your server, and somebody hacks your server and gets access to that file. They can read it, and then they've got your database password. Or they do something other, idiotic. Like you see, like they check crap into source code. Like I don't know how many people have embedded AWS keys into their GitHub and then made it public because they're idiots. So what we're going to try to do is I'm going to try to use KMS. So what this will do is basically we will encrypt keys, store encrypted data in S3, and server pulls down keys, decrypts using KMS, and instance profile credentials. And then we keep the keys in memory. So I think that's what I'll do for credentials. Health and monitoring. I really just think we're going to have some really basic CloudWatch. Basic CloudWatch monitoring. And let's also make sure we can do remote connect JVisual VM profiling. And we'll use our log to file locally. I don't think I'm going to need like a whole Elasticsearch cluster or some other bullshit to pull stuff off, so I don't think that's going to be an issue. Do I need a service monitor? Yeah, I should probably have a local service monitor to restart stopped services. That's a question mark. We may not need it. Yes, Unreal 4 is the front end. There really isn't front end and back end, to tell you the truth. Well, Chris Goku, yeah, there definitely is a separation between front end and back end. In the context of the game, usually not. Usually what you'll do is you'll have a game server and a game client for like a dynamic instance-based game such as like League of Legends or Call of Duty. Most of the time, the client and the server are pretty much the same code, C++, and they run on instances. And then you have the quote-unquote backend, which is the system that manages all the backend crap, like your authentication, login, message passing, matchmaking. Usually that is a separate system. And yeah. Alright, so what are we going to do for our wire protocol? So let's do HTTP wire protocol. I think I'm just going to use JSON. So auto-generated JSON messages should be just good enough for that. And I think for our TCP protocol, we're just going to use protobuf. Google protobuffers are a message format which is binary. I would not use flat buffers ever because security issues. I would recommend protobuffers because they work. They're a lot more secure, better. I am working on some server designs for the back end and figuring out what I'm going to do for that. So that'll be the wire protocol. We're going to use the encryption. For that is going to be AES encryption with the HMAC 256 signature. And of course, for our encryption for HTTP, we're just going to use SSL and TLS3. And that's going to be terminated on load balancer. So if you're not familiar with a lot of server technology stuff, pretty much if you're going to do anything secure, you got to do it through like some sort of HTTPS, SSL, TLS. And a good practice is to have your load balancer do SSL termination. So basically, as a message comes through from the client, it'll go to a load balancer, which distributes requests to servers behind it. And the load balancer can have all the auth keys and stuff like that for actually decrypting the data, and then you send the data unencrypted as soon as it's inside of your kind of protected data center. And it's there's some arguments against it, of course, but I think one of the big arguments for it in modern server stacks is nobody has your SSL certificates except for your load balancer, and those systems can usually be super secure. And if somebody steals your SSL cert, you're pretty much screwed. Bad things can happen there. To have everything encrypted on the back end is better. So, but you can use certain things, other techniques for that. Usually, like the AES, HMAC stuff is usually good enough for that sort of stuff. Alright, so that's that. Looks like it'll cost us like 50 or 60 bucks a month to run the whole server stack if we use one load balancer, one server, and one RDS instance. I'm gonna have to build all this crap, aren't I? So I need an HTTP server and a TCP server, and I need to auto-generate the whole goddamn layer for the thing, and that's gonna be a big problem. Alright, well, let's set stuff up then. So I'm going to make a new project, and that's where I'm going to stick all the game stuff, and I'm going to keep game-specific stuff out of this utilities. So this will be WD Dashkin services. I'll just call it Dash services. Alright, so let's crack open our WD Dash services. I usually like to edit these Eclipse files directly. Alright, so we're going to take out... Is anything even in the test folder? Let's get rid of all that trash. Let's make sure we actually have a folder there. Your whole team in one person? Yes, that is true. Alright, so we got all of these things. Simple stuff like stack and heap. Yeah, that's true. Alright, looks like I have to get all this crap into Perforce before it's gonna let me use it with the plugin. Hello, Karakan. Well, I mean, I worked for 8 years doing game servers and working on all sorts of random stuff, so I mean, there's always a billion things to learn with this stuff. But I'm kind of a workaholic, so I've done a lot of random bullshit. It's probably just more specialized stuff that I am familiar with. That's about it. Alright, dash services. Let's import this piece of junk. This thing's gonna be all angry because our build path is gonna be jacked up to hell. So remove all that. Get all that set up. Let's set up our dependencies a little bit. Can I get rid of that fucking overlay? Get out of here, Spotify. Fuck off. Why is this giving me a warning? I don't. Anyway, alright, so we'll go to our order export for this thing, and we're gonna make sure that this thing is exporting all of our jars. And we're gonna start off by setting up our export and build process for this stuff, just so we have a good clean sandbox to start with. How am I doing? I am doing well. I am starting on some new stuff though. Alright, so we're gonna need a new package here. Alright, so how I like to set up my stuff is that this is kind of a tiny font here for everything. Water's done for now, yes, it's true. How I like to run all this stuff is I like to put all of my executable stuff into one single jar. And a lot of Java stuff, usually you'll have like big configuration bullshit going on, and I don't do that. What I do is I make it so that like a single jar file, kind of how the command line pass in to run a jar file is to like run a Java jar. Um, is that's your command line to do stuff, and this is all well and good, but normally you'll have like a jar file which has like a whole bunch of other garbage next to it. So what I like to do is I like to make one jar file which has everything in it, and then when you pass the first command line argument should be the name of the program. So I usually do this sort of setup, so just java myjar.jar and then my program, and then I put all these like program names and sort of stuff in these maps, and then you can then call into the program and use reflection to find the main and then run it from there. So it's kind of, it makes sense if I don't know, it makes sense to me. So basically, like, we make a new main file for Java. So this is our main Dashkin server startup area. Let's see, I need to, this is kind of how I start stuff up. So stuff like that. You should really learn .NET. Cool watching. Go finish ours. All right, Chris Goku. Have a good time. All right, so basically what I can do in this main is I can then reference this w-server, and I'll be able to actually start that up. All right, so if we actually run this, it's just going to print out starting up Dashkin server, and then it's going to shut down because there's nothing else for it to do. All right, so we need to